This experiment was taken from Modern Experimental Organic Chemistry, 3rd edition, by Holt, Reinhardt, and Winston. Welcome back to my series on liquid-liquid extraction. This chapter covers using the separatory funnel and extracting each of our solutes into 3 separate solvents. The separatory funnel has 4 main components: the flask itself that holds the liquid, the glass stopper at the top, the stopcock, and the stem. The glass stopper at the top should stay inside of the flask while performing an extraction, otherwise your fluid will fall out of the flask. The stopcock controls whether or not liquid can fall through the stem at the bottom. In the vertical position, the stopcock is open. In the horizontal position, the stopcock is closed. This means that the flow of liquid can be controlled, allowing us to easily separate 2 layers of solutions, such as aqueous and organic solutions. The separatory funnel I'm using will be placed into a ring stand like so, while I'm adding liquid through the top of the flask, or using the stopcock to remove liquid from the flask. When using the stopcock to pour liquid out, the glass stopper at the top should be removed to remove all pressure from the system. Now, before we begin the showcase of the extraction, I will be honest, because science isn't perfect. During my project, I lost the original footage of the full extraction I did, but I still wanted to show you guys how it works. To save materials, I recreated the reaction with half the moles of the original reagents and half the milliliters needed of 6 molar HCl and 3 molar NaOH. What this means is 1 gram of naphthalene, benzoic acid, and p-bromoaniline were dissolved in 50 milliliters of DCM, and 30 milliliters of 6 molar HCl and 3 molar NaOH were used. I'll note the differences from the original extraction as they happen, as there were some changes I observed with how the reaction carried out. Despite this change in the video though, I will still be referring to every reagent with the original amount that is called for to allow you to follow along. Nevertheless, let's continue. The procedure calls for the 100 milliliters of your organic solution to be poured into the separatory funnel. Then, 60 milliliters of HCl should be added into the funnel. Here, you'll notice I only measured out quote-unquote 30 milliliters. This is because as the HCl gets added, it's over the course of 2 washes, so 60 milliliters will be added in total. This brings me to my first difference I noticed. I noted that in the original extraction, this also happens, but not as drastically. Now, what I do here is I slowly and carefully take the separatory funnel off and hold the glass stopper at the top with my left hand. If you have a stopper with a thin glass circle at the top, that disc can be slotted in between your middle and ring finger, allowing your hand to put full pressure on the glass stopper. I don't have that here, so I just cup the stopper as much as I can and begin to press down on it to keep it in place. I then begin to tilt the separatory funnel back and forth, stopping every now and then to turn the stopcock to the vertical position. You'll hear a hissing sound. This is gas being released from the flask as pressure builds up inside the flask during the reaction. It is essential you do this every few seconds and make sure the liquid is on the side of the glass stopper. For best results, try to make sure your separatory funnel is at the max half full. Once you've shaken it enough to the point where there isn't any more gas leaving the funnel when you open the stopcock, you should be good to stop. Place the funnel back on the ring stand with the stopcock in the horizontal position and then put your receiving flask under it. Turn the stopcock to a vertical position and pour that in your organic layer flask. You can open and close the stopcock as you begin to pour out the last of 1 layer and the beginning of the second layer. Try to get as close as you can to not mixing the layers, but just do your best and be efficient as possible. The other layer, which I already took out of the funnel, was the acid wash layer, which should be in its own flask. Repeat this process with 30 more milliliters of HCl. You'll notice it continues to stay a milky white color despite how hard I shake it. I wouldn't recommend shaking the funnel like this if you're new to using the separatory funnel, but this is a way you can oscillate the funnel when you're more comfortable with using it. Separate the acid wash layer and the organic layer again. We will be putting the organic layer through 2 more washes with 30 milliliters of 3 molar NaOH next. You'll start to notice some changes here as well. The organic layer has cleared up a little, meaning that it is reacting with the NaOH to extract one of the solutes from the organic layer. The continuing process follows the same steps as the acid wash. Tilt the funnel back and forth or shake it, turning the stopcock to release gas every few seconds. Then, separate the layers with your stopcock and pour out your base wash. Then, take your organic layer and wash again with 30 more milliliters of NaOH. Finally, we have each of our 3 layers: the base wash, the organic layer, and the acid wash. The next step for the organic layer is to add sodium sulfate, and for the acid and base layer, they need to sit in a bath of ice for at least 15 to 30 minutes. You can set up your organic layer while this is cooling. Adding sodium sulfate means that you're adding a drying agent to your flask and organic layer. It will remove any extra water from your system to leave just naphthalene and the dichloromethane inside the flask. The procedure calls to add 4 to 5 grams of the solid, which looks like this. Leave this in for 30 minutes and swirl occasionally. Once half an hour has passed, grab a new flask and a large filter paper circle. Flute the filter paper as shown in the diagram, then unfold and place it in your new flask, but not all the way. You're about to perform gravity filtration, which will allow your organic layer to filter through the filter paper while your sodium sulfate sits on top of the filter paper, effectively being removed from the organic layer. Thanks for watching, and I'll see you in the next video.